Stargazers and astronomers are shocked by the upcoming disappearance of the North Star, Polaris. This event is anticipated to be the next big thing in the sector of astrophysics. Yes, you heard that right, Polaris is set to be rubbed off our starscape for good, and this approaching celestial cataclysm carries profound implications for our ground-based telescopes, which use it as a reference point for their calibration and accuracy. Brian Cox warns that Polaris's explosion is approaching and could change the nighttime sky forever. Let's delve deeper into the tale of the North Star and why it matters so much. For millennia, Polaris has been a celestial guide for both astronomers and navigators, but all of this may change in a matter of decades, if not years. A recent research work presented to the esteemed Royal Astronomical Society in September 2023 has all but sealed the fate of this guiding light. Polaris is on the brink of a cataclysmic event and explosion that could result in its disappearance from the night sky, forever changing our cosmic compass. But before we delve into the potential consequences of this revelation, let's explore the star in question. Also known as the North Star or Pole Star, Polaris holds a unique position in our night sky due to its proximity to the celestial North Pole. It sits almost directly above the Earth's North Pole, giving the illusion of being almost stationary in the northern sky, positioned within the Ursa Minor constellation, which is also known as the Little Dipper or the Small Bear. Polaris shines as a moderately bright yellow-white supergiant star. It outshines the Sun in luminosity, radiating significantly brighter across the cosmic canvas. Furthermore, in terms of sheer size, it dwarfs our Sun, boasting a radius estimated to be approximately 40 times larger. Despite its apparent singularity, Polaris is part of a complex triple star system. Of these, Polaris AA and Polaris AB appear as a single star to the naked eye. A third companion, known as Polaris B, orbits this binary pair. The problematic gravitational interactions among these stars influence their orbits and luminosity. These complex dynamics can cause irregular variations in the star's brightness and pulsation patterns, but the exact mechanisms behind these interactions remain a cosmic enigma. On top of all of this, the awe-inspiring distance of Polaris from our planet adds a fascinating temporal twist to our understanding. Since it is 323 light-years away from us, the light we perceive from Polaris today embarked on its interstellar journey over 3 centuries ago. If we were to see Polaris explode at this very moment, it would have actually occurred all those years ago. The Earth 323 years ago was quite different. In the early 18th century, humanity was navigating through a period marked by significant historical events and cultural shifts. It was an era marked by the end of the Renaissance period, the beginning of the Enlightenment, and the dawn of the Industrial Revolution. In some parts of the world, scientific advancements were gaining momentum, with figures like Isaac Newton forever changing the scientific landscape. In terms of daily life, society was still largely agrarian, with farming being the primary occupation for most people. Urbanization was gradually picking up, leading to the growth of cities and the expansion of trade and commerce. Culturally, literature, music, and art were finding prominence. So, if Polaris explodes tomorrow, it would have done so at a time when Earth was amidst a period of transition, exploration, and change, setting the stage for the developments that would shape the centuries to come, not unlike how this event could change things for our future. Throughout the centuries, the North Star has woven its significance through the tapestry of civilizations. This stellar beacon served as a guiding light for ancient seafarers and travelers, illuminating their paths across vast oceans and unknown terrains. Polaris is a reliable reference point, guiding explorers in the Northern Hemisphere, allowing them to chart courses with confidence. Polaris has embodied a cultural and navigational cornerstone for centuries, shaping the narrative of ancient explorers, storytellers, and scientists alike. So, how do we know that the star is nearing its end? Classified as a Cepheid variable star, Polaris has very specific properties and cosmic measurements. Its predictable brightness fluctuations have been instrumental in unraveling mysteries about variable stars and calibrating astronomical instruments. These rhythmic pulsations have historically followed a reliable pattern, helping astronomers in predicting its behavior with ease. However, in the aforementioned research paper, scientists exposed a deviation from this expected pulsation cycle that has startled the astronomical community. Polaris has taken on an erratic, unpredictable rhythm of dimming and brightening. This irregularity has prompted intense scrutiny, with astronomers grappling to understand this celestial anomaly. This departure from its norm has sparked concerns among scientists, hinting that Polaris might indeed be approaching the twilight of its life. Polaris's pulsation period has recently begun stretching. The star was previously stable in its cyclic brightness shifts, but now astronomers have noted a progressive lengthening of the pulsation period, with an annual increment of 4.5 seconds. While seemingly minute, this alteration holds significant cosmic significance, signifying a substantial departure from its established behavior. There have been various speculations on the matter. Some attribute this shift to gravitational interactions within the Polaris star system. These interactions could be altering the star's atmospheric conditions, directly influencing its pulsation patterns, or more specifically, how we perceive them. But dissenting voices in the scientific community suggest a far more alarming possibility. The star is dying. Whether it's a result of gravitational interaction or a harbinger of an impending stellar explosion, the irregularities in Polaris's behavior have ushered in a new era of cosmology. Either way, the reality is set to change everything we thought we knew about triplet star systems like Polaris. Speaking of how revelations change our worldview, it was in 2006 that we got a close-up look at Polaris courtesy of the Hubble Space Telescope. Astronomers also unveiled the elusive companion star, nestled so intimately close to Polaris that it had been impossible to study it beforehand. This was the first ever photo of our celestial neighbor, capturing its ultraviolet light. Today, we know that the companion, Polaris b, orbits the central duo at a distance of approximately 2 billion miles. Although astronomers had inferred its existence from light analyses of the triple star system nearly 50 years ago, its faintness compared to Polaris obstructed direct observation until the Hubble Space Telescope made it possible. This all began with the launch of the Hubble Space Telescope, HST, in 1990. Its deployment opened a window to the universe, offering unprecedented clarity and redefining our comprehension of astrophysics. The HST captured celestial marvels that reshaped our fundamental understanding of space. Among its iconic achievements stands the awe-inspiring image known as the Pillars of Creation in the Eagle Nebula, which houses massive columns of gas and dust where stars are born. Another landmark moment came with the revelation of the Hubble Deep Field, a seemingly empty patch of space that, upon closer scrutiny, was teeming with thousands of galaxies. This single image expanded our perception of the universe's sheer vastness and complexity. The HST also studied exoplanet atmospheres and unveiled tantalizing clues about their composition. The presence of elements like water and organic molecules in these far-flung realms hinted at the tantalizing potential for habitability beyond our solar system. Building upon the legacy of Hubble, its successor, the James Webb Space Telescope, JWST, was launched to push the boundaries of technological innovation further. With lessons learned from Hubble's endeavors, the JWST stands poised to propel us deeper into the mysteries of the universe, continuing the legacy of exploration and discovery initiated by its esteemed predecessor. One of the JWST's standout features is its unprecedented ability to capture celestial vistas with striking clarity, banishing the murky shadows that once obscured our cosmic observations. The telescope operates primarily in the infrared spectrum, piercing through cosmic dust veils and unveiling celestial treasures previously hidden from human sight. At its core lies a massive 6.5-meter primary mirror, composed of 18 hexagonal segments, dwarfing Hubble's mirror in sheer size and sophistication. Located approximately 1.5 million kilometers away from Earth at the second Lagrange point, L2, the JWST gracefully trails Earth's orbit around the Sun. From there, it offers us an unimpeded and steady gaze into the cosmic net. Yet, the voyage into the cosmos is not just a journey across light years. It's a journey through time itself. The JWST employs state-of-the-art infrared detectors capable of peering billions of years into the past, capturing the ancient light emitted by celestial entities as the universe expands. This light undergoes a transformation called redshift, shifting from its original visible spectrum to the infrared wavelength or longer. The JWST is ideally suited for detecting and interpreting these infrared signals from remote celestial bodies. And now, it is all set to revolutionize our understanding of Polaris as it reveals clearer than ever images of the triplet star. This innovative telescope has heralded a new era of astronomical exploration, poised not just to unveil the remote reaches of the cosmos, but also to unravel the mysteries of our cosmic past. With its exceptional capabilities and unique vantage point in space, the James Webb Space Telescope stands as a beacon of human ingenuity, unlocking the secrets hidden within the celestial expanse. To this point, we know for a fact that there are intriguing parallels between Polaris and Betelgeuse. Both of these giants are said to be nearing their ends. Betelgeuse is a prominent star in the Orion constellation and has showcased troubling irregularities in its luminosity, similar to what we found in Polaris. This resemblance has prompted experts to contemplate the possibility of an impending stellar explosion in the next few centuries. While it may sound alarming, the demise of these massive celestial bodies has sparked immense interest among astronomers and cosmologists alike. Betelgeuse's eventual explosion, expected to occur as a supernova, promises to be a spectacular event, dramatically transforming the night sky with its bright, explosive display. So, the horizon is indeed brimming with celestial wonders and mysteries. We await with bated breath to see whether Polaris will undergo this anticipated transformation, and if so, what revelations it will bring to the cosmic stage. The legacy of the North Star, intertwined with our navigation, history, and understanding of the universe, will forever remain etched in the annals of astronomy. As we stand on the cusp of this cosmic evolution, let's stay tuned and prepare for the celestial upheaval that could reshape our view of the universe as we know it.